of compounds, that have different empirical formula, molecular formula, and structural formula. Ethane has CH3. The molecular formula is C2H6, while the structural formula is CC surrounded by H with only single bond. Ethane have a empirical formula of CH, but molecular formula of C2H2. But the structural formula have two triple bond, two carbon having triple bond. While for benzene have a empirical formula of CH and the molecular formula of C6H6. Then this C is now in a ring structure having a kind of two double bond in carbon surrounded by hydrogen. The empirical formula is first determined. By definition, the empirical formula represents the ratio of atoms of the element in the compound. The percentage of each element in the compound is usually given or can be worked out from the equation. The percentage of each element is divided by the relative atomic mass of the element to give a number of each element by the number of smallest atom and approximately to the nearest integer. Example 1. A compound contains 85% carbon and 16% hydrogen. Find the empirical formula. Solution. Look at the element of carbon, which is C, and the element hydrogen, which is H. The percentage composition of carbon, C, is 84, and the percentage composition of hydrogen, H, which is 16. Dividing the percentage composition by the relative atomic mass, we see that 84 divided by 12 will give us 7 for carbon, and the 16 divided by 1 will give us 16 for hydrogen. Then divided by the smallest number, that is the smallest one that gives us the smallest answer. Since carbon gives us 7 as the answer, which is smaller than 16, we now say that 7 divided by 7 will give us 1, and 16 divided by 7 will give us 2.28. To the nearest integer, we have that the ratio is now equals to 1:2. Therefore, the empirical formula will now become CH2. For the molar mass, example 2, the molar formula of the compound is next determined. The data required for these are the empirical formula, B, the molar mass of the compound, or vapor density of the compound. Example 2. Analysis of a sample of organic compound shows that it contains 39.9% carbon, 6.9% hydrogen, and 53.2% oxygen. A. Calculate the empirical formula. B. If the relative molar mass is 60, what is the molar formula of the compound? Having that C is equals to 12, H is equals to 1, hydrogen is equals to 1, oxygen is 16. Solution. Looking at the compounds of the elements that make up the compound, you see carbon, we have hydrogen, we have oxygen. Then the percentage composition by mass of carbon is 39.9. Of hydrogen, we have 6.9. Of oxygen, we have 53.2. Dividing the percentage composition by mass with the relative atomic mass to get the ratio of the atom, we have 39.9 divided by 12. 12 is the relative atomic mass of carbon, which will give us 33.33. 6.9 of hydrogen divided by the relative atomic mass of hydrogen, which is 1, which will give us still 6.9. For the oxygen, we have 53.2 percentage composition of oxygen divided by 16 relative molecular mass of oxygen, which will give us 3.33. Then divide by the smallest number or the smallest answer, the one that have the smallest answer, which is 3.33. We now have 3.33 divided by 3.33 for carbon, which will give us 1.00. Then for hydrogen, we have 6.9 divided by 3.33, will now give us 2.04 for hydrogen. While for oxygen, we have 3.33 divided by 3.33, which will also give us the 1. Therefore, the empirical formula is still 1:2:3. Therefore, the empirical formula of the compound will now be CH2O. CH2O. Now, the ratio of the atom is obtained by dividing each percentage composition by the relative mass, atomic mass of the element. Since the molecule must contain an integral number of atoms, the values are all correct to the nearest whole number. The substance therefore contains carbon, hydrogen, oxygen in a ratio of 1:2:1, as I have already said. Therefore, the empirical formula of the compound is CH2O. Now, for the second question, says that if the relative molecular mass is 60, what is the molar formula of the compound? The molar formula of the compound is a multiple of the empirical formula, that is H2 times N, where N is a whole number. The relative molecular mass of the compound is the sum of the relative atomic masses of all the atoms in the compound and is equal to 60 from the question. Therefore, H2O is equals to CH2O is equals to 60. Therefore, getting the relative atomic molecular mass of each of the atom in the compound, which is 12 for carbon, 1 for hydrogen times 2 atoms of hydrogen, plus 16 relative molecular mass of oxygen, times by N, which is equals to 60. Then, if you add up this number, we have 30N, which is equals to 60. Then, if you cross multiply, we now have that 60 over 30 is equal to 2. Therefore, the molecular formula of the compound is C2H4O2, since 2 is the N, times in the C2H2O2. Alternatively, looking at the elements C for carbon, H for hydrogen, and O for oxygen, the relative mass of carbon is 2 grams, for hydrogen is 0.34 grams, and for oxygen is 2.67 grams. The molar mass is for carbon is 12.12 gram per mole. For hydrogen is 1 gram per mole, while for oxygen is 1 gram per mole. Then the relative mass divided by the molar mass